we are again. I've just finished Advent of Code day 9. I'm not going to put a video up for all the days of the Advent of Code. I'm just going to focus on the one that I'm finding the most engaging. And day number 9 was very nice. So the idea is that you have this height map, as you can see here, where you have various heights from 0 to 9. And you want to find a place where there are basins. So that is the places where the height is at its minimum with respect to the neighborhood. And here we just check for the neighborhood for up, down, left and right, and not the diagonal. And then once you have found those minimum point, they will become a seed for a basin. That is, the basin will grow around them up to the point where we reach the ridges of this map. That is the pieces of ground with height 9. So let's see how I've solved it in 42. So to solve this in 42, as usual, I'm importing Adam Towel and the file system library, and then I'm using a matrix. And a matrix in Adam Towel is a wrapper around a list, in this case a list of indexes that are sufficient to keep our heights from 0 to 9. The matrix also have a nested class coord that represent coordinates inside of the matrix. And thanks to invariance, those coords can only be points inside of the matrix. We make a list of coords that will become the list of our seeds for our basins. And then, yeah, we should probably add this to Adam Towel, a way to split on a string so that you simply see every character individually. The static method near is probably the most crucial part of my solution. The idea is that since thanks to invariant the coordinate needs to be valid, I can make a new coordinate by adding +1 to a row, or +1 to a column, or -1 to the row, or -1 to the column. And if that will go into an invalid coordinate, I will just get an error that I can capture and ignore. Instead, if I successfully created a new coordinate, I can add it to a list of coordinates I'm creating. We have 4 blocks that are working like a try-catch in 42, where we initialize the variable new, and if there is any error, we just discard it, otherwise we add the new coordinate to the list of coordinates that we are creating. The main of the solution works by reading the input as a string, making a matrix where for all the line of the input, for all the character in that line, we just add this character to the matrix as an index. Since we have a matrix that is 100 by 100 and we have exactly the right amount of characters, we can just create the list that initializes our matrix in this way. We now have to discover the seeds for our basins, that is, the points that are only surrounded by points that are higher. And we can make a list of those seeds by creating a list of coordinates, and then for all the coordinate in the possible set of coordinates for this matrix, accompanied by the corresponding height of the matrix in that point, is our current point a minimum? We can discover it by checking that for all the coordinate ci near to our coordinate, it so happens that the height of the matrix in that coordinate is bigger than the current height. And then, if we have found a minimum, we just add it to the seed. While doing this puzzle, I realized that I could use high numbers to mark those basins without getting confused with the possible height level in that point. So for all seed C in position I, I'm marking that coordinate C with a unique high number, that is 100 plus the index of this seed. So I'm going to have the seed marked with 100, the seed marked with 101, 102, 103, and so on. I then define 2 static methods, need more and grow basin, where needs more checks if we need to keep growing our basins, and grow basin is growing the basins of one step. Needs more is pretty simple to implement. We just check if there is any element in the matrix that is less than 9, because 9s are the ridges and we want to keep the ridges, and all of the other elements will become 100 plus something once we have finished growing all the basins. So if we found some element less than 9, we haven't finished our work at filling up. Grow basin is quite interesting. We take the matrix as a mute parameter, and then for all the coordinates, all the possible coordinates on this matrix, for all the corresponding height in this matrix, if the height is bigger or equal than 9, we don't have to touch it. So we continue on our iteration in the for. Instead, if the height is less than 9, we take all the coordinates near this height. And if the coordinate is more than 99, that is, the coordinate have been tainted to be part of one of the basins, then we propagate this taint. So the current height becomes this height bigger than 99. In this way, by simply doing while needs more grow basin, I can completely grow the basins and fill them with a unique number that will recognize and distinguish them from each other. The puzzle wants now to discover what's the size of the 3 biggest basins. So we start computing the size of all the basins, and again, the basins are connected to an index, that is the index of the corresponding seed. And so we can get all the sizes by doing a list of indexes, and for all I in range of seed.size, that is, for all the possible seed index, we just add how many values there are that are really equal to I plus 100 for all the value in the matrix. So we explore all the values in the matrix, and every time we found a value that is equal to I plus 100, we add it to the ith seed size. Then I made a boring function popmax that takes the list of size and gives you the max element and remove it from the list. And then I can just multiply the top 3 elements. And yes, I'm soon going to add to Adam's towel some way to play with max, minimum, average, and so on lists. This is all for today. If you enjoyed this video, please like and subscribe, and see you for more interesting 42 facts.